Welcome to my projectbazaar.com.
Now we discuss about the abnormal crowd behavior detection by using the particle entropy. In this process, we track the human for identify the abnormal event in the overall crowd. Here we want track the multiple persons in the one video camera. Here we use the several cameras for detect the human by using the normal tracking method. In this tracking method, we use the particles for track the human. In this process, we generate the particles and then we assign the each particle and the each person in the video, and that the particle will be movement based on the foreground movement. Like the human will be movement, the particle also movement, the direction and also the velocity of the human movement. In that movement will help to identify the entropy of each particle. That entropy of each particle will be help to identify whether the crowd is normal or abnormal. In this process, we use the GMM classifier for classify the entropy ranges. That entropy will be calculated of particle based on the movement of human and with axis and also the velocity, and use that entropy we easily calculated the abnormal event in the videos. Now we go to process of our flow diagram. It is our flow diagram for our process. Now we give the video for input. Then the video will be converted to the frame. Then that frame will be preprocessed by the Gaussian filter. After preprocess, we subtract the background for identify the foreground because of the tracking the human based on the background subtraction. After the background subtraction, we allocate the particles for each foreground images. It is the object tracking process. After the particle allocation, then we calculate the entropy based on the particle movement. The particle movement will be taken by the axis of the particles and also the velocity of the particles. That axis and velocity of the particles will be used to calculate the entropy of each person. After the calculate the entropy, then we use the GMM classifier to find out the variations of abnormal and normal. First we train the abnormal and normal entropies will be trained in the GMM classifier. Now we give the input of the GMM classifier with the entropy, and then that GMM classifier calculate the test entropy with the train entropy, and it will be give the result whether our given input entropy will be the normal or abnormal. Now we going to demo of our process. Now we going to demo of our process. First open the MATLAB and then open the source code folder and then right click the main.java folder and then run the file. Now open that dialog box, click the dataset folder and then open the any videos in the dataset, and then it is automatically convert the frames in the video. Now if we want play the video, then click 1 and hit enter. Then your video player will be open for play the video. Now it is for player for running the video. Now I run the video. Here the crowd will be there, and certain time the crowd will be abnormal. We detect that abnormal by using the GMM classifier and also the entropy calculation. Now hit the enter to preprocess the frame. Now the frames will be preprocessed and also it will be count the overall frame. Now our input video there is 100 frames will be there. After the preprocessed frame, the background subtraction is automatically generated. Now it is our background subtracted image with each frame. Now it is the entropy calculation based on the particle tracking. After tracking the GMM classifier, find the abnormal in the crowd. Now it is the comparison chart for existing and proposed work. Our proposed work will be the nearest to 90% accuracy, and also our existing will be the 80% accuracy. Here is the accuracy of our proposed work. Now it is our output video for abnormal detection, and then it is the particle movement, and it is the entropy variations of based on the particle movement, and then it is the preprocessed frame. Now I will go to open the another video for checking the process. Now I right click the main.m and then run the file. Then we go to the dataset and select the any video from the dataset. Now the frame conversion is done. Now I will hit the enter or directly go to the preprocessing step. Now here the frames will be preprocessed. After preprocessed, automatically the background processing will be done. And then it is the background processed images. Then the particle will be assigned based on the background subtraction and the entropy will be calculated here. Then it is find the abnormal code here. Here the ground will be there and
take the final result of our proposed work. The accuracy will be find out the overall process. Now our process accuracy it is the 97.286% and the sensitivity will be the classifier sensitivity. It shows how the classifier analyzes a result with perfect sensitivity rate. Now our proposed work sensitivity will be the 0.9%. The specificity also the specificity of our classifier, and the error rate will be the wrong classification of our classifier. That result will be based on our feature extraction and also the classifier accuracy. Now we extract the feature is very well, and also we use the very perfect classifier for that feature extraction. For that reason, our proposed work accuracy will be improved at the 97%, and also the sensitivity of the classifier will be the 0.92 is equal to 92%. So that reason the accuracy will be improved. It is the comparison graph of both existing and proposed system. The existing will be the 86% above equal to the 89%. Now the proposed will be the 97%. It is shown in the message box. So in this graph shows now our proposed system will be improve its accuracy compared to the existing system. Because of the existing, the tracking rate will be low, and also the feature extraction will be low, and the low sensitivity classifier will be used. So that reason the existing graph will be the low accuracy. Now the proposed will be the get high accuracy for the feature extraction and also the classifier sensitivity. Thank you.